This is my fourth attempt at doing this video, so whatever happens, I am pushing through to the end. Sorry if it's a rocky road. So welcome to Algebra 2, Unit 2, Lesson 3. Really more like Lesson 5 because we took Lesson 2 and we broke it up into smaller chunks so we could look at each form of a quadratic individually, but here we are. So this lesson is going to focus on applications of quadratics. These are our word problems, which I get excited about because this is what I think is interesting about math. Now, the main tool that we're going to use for this lesson is Desmos. So we're going to approach the word problems and the application context with the graph, okay? More with the graph than with the mechanics of the algebra. We can do either or. This particular lesson is going to be Desmos based. The goal of the lesson, if I can find my mouse, there it is. The lesson goal is to be able to locate key points on the graphs of quadratics as they apply within the context of a word or application problem. Like I just said, I love word problems. Word problems for me is where the math gets interesting. So I want you to try to keep that frame of mind. Not that word problems are hard or they're tricky, but that they are interesting because they take what we've done with just X's and Y's that may or may not mean anything to us, and it pulls it into a context where those variables have meaning, where they represent the things that we interact with every day in the real world. All right. Now, there are key points on quadratics, and none of these are new, so this is all review, but I do want to make sure that we're on the same page with our vocabulary before we go any further. So when you're dealing with quadratics, there are three main categories of key points. One of them is the vertex. So the vertex, if the parabola opens upward, would be the low point or the minimum. If the parabola opens down, then the vertex would be the maximum or like the highest point there. And so if you're doing a word problem and it asks what is the lowest or what is the highest, okay, probably what you're being asked for is the vertex. So that's like word problem code for find the vertex. The y-intercept is the point where the parabola crosses the y-axis. So if you've got your XY axis and you've got your parabola on it, and guys, somewhere that parabola crosses the Y axis. You might also be interested in the x-intercepts. So those points are where the parabola crosses the x-axis. And then we already mentioned the vertex on this one. The vertex looks like it would be right about there. Okay, now you may also need to apply the ideas of increasing, decreasing, positive, and negative. Those are not super common with this particular type of problem, but that doesn't mean you can't be asked anything or that it's not important that you know how those concepts apply within the context of the problem. So as we go through these, hopefully I can remember to bring those ideas in as well, and I don't get too wrapped up in just what the questions are. So there are actually tons of things that are represented by quadratics in the world outside of our like little four walls of our math classroom. So I'm thinking of like kinetic energy. This is a lot of stuff, but there's one like main common application that we use at the Algebra 2 level. So if a teacher wants to give you a word problem that has to do with quadratics, this is probably what they're going to give you. Not saying that's 100% sure or that there's nothing else you can see. There are tons of other things that you could see that are modeled by quadratics, but the most common one and the one that we are going to focus on is projectile motion. So projectile motion is when objects are thrown or dropped and are influenced only by the force of gravity. So I know in one of my Algebra 2 classes this year, and I usually do it in all of them at some point, I will throw something across the room. And you know from your actual life experiences, okay, so you're standing there and you throw something and the path of the object, okay, looks something like that. And it's not making up that like, oh, this is like sort of like a parabola. It's a parabola, okay? The only thing that might influence the paraboliness, like the perfect mathematical parabola there is air resistance. Okay, so whatever it is that you're throwing, the air is going to create some friction, and so you don't actually have the only force being gravity because there's going to be some friction due to air resistance. Usually that is negligible though. So most of the time, if we're sitting in my class and like, I mean, don't do this because it's bad, but somebody wants a pencil and somebody, chucks a pencil across the room at them, it takes the path of a parabola. You can see from the little sketch here, like there's a highest point. And so the object leaves the person's hand, it goes up, it reaches a highest point, and then it begins to come back down, and eventually it will hit the ground, the desk, the person, who knows. All right. All of these could be questions that somebody might ask. Okay. And so you might be asked, what is the highest point? Or when does the object hit the highest point? You might be asked, when or where does it hit the floor? You might be asked, what was the starting height? Or you could be asked something like, how high was the object after 2 seconds? So maybe after 2 seconds, it's here. And so you would plug a 2 into the formula. In terms of positive and negative, positive means that the object is above the floor, and negative would mean that it sunk into the floor. Now that isn't, we really hope that doesn't happen in class. I don't want to think about what would sink into the floor, but that's what the context would be. Increasing would mean that it is gaining height. Decreasing would mean that it is losing height. And so we have all of those concepts at play. Most of your application problems at the Algebra 2 level are projectile motion. And there's two ways to think about it. One way is like with your X and your Y. So this particular example, you'd have like the height is the Y, and then the horizontal distance would be the X. Maybe a little bit more common is using time on your X axis. And I have had a few students ask me why it's still quadratic, like even if an object goes straight up and straight down, because you don't see the parabola. That's because the relationship of the height to time is also a quadratic relationship. And that's something you could explore a little bit more in a physics class. So here are the typical connections. Okay, so this is maybe my version of a cheat sheet for this. If you're watching this from home, feel free to like write this down on a scrap piece of paper. But more importantly is that you're just kind of paying attention to where we're going to go with this. So the y-intercept is typically the starting height. If you think of a coordinate plane, the y-axis is when x is equal to 0, and a lot of times that'll represent when time is equal to 0, so it would be the starting height. Okay, and I probably need to erase that because I think my next thing is gonna cover it. Let's see how. That's not too bad. The vertex is when the object reaches its highest height. That would be the x, and what that highest height is, that's the y. So remember that your vertex does have an x coordinate and a y coordinate. And it says there both of those questions may be asked or just one. So sometimes it's just how high does the object go? If you're asking for how high, height is your y. Okay, so you would be asked for the y coordinate of the vertex. If the question is when does it reach the highest height, that is going to be the x coordinate of the vertex. Sometimes a problem might say, what is the highest height and when does it get there? Okay, well now you're being asked for both. Sometimes only one of them are asked. Is asked. Now, if the x-axis is not time, then it might represent horizontal distance, in which case it might be where does the object hit the highest height. Keyword there, though, is when you hear highest height, it's going to have something to do with the vertex. Okay, so you got it narrowed down to like it's one of two numbers. Next one is, my mouse is gone. There it is the x-intercepts are when or where the object lands. So typically when we are modeling this, we will model the ground or like the floor with the x-axis because it's a natural thing to do. You don't have to do that, but you're making your problem unnecessarily complicated if you don't. And so that would tell us when or where the object lands. And then I have here, these are general ideas. Individual problems may have some differences in how the concepts apply. So that's why I said, if you want to write this down, fine. But writing it down is no substitute for just thinking about the problem that you have. Okay. And your problem might be different. All right, so for task number 1, so these this came from like a wonderful like set of problem tasks that I got years ago. So we're basically going to do this with the Desmos calculator. So I've got it up on the right, and then we have the problem on the left. Task number 1: your nephew is standing on his deck, which is 4 feet off the ground. He tosses his toy up into the air at an initial velocity of 7 feet per second. The equation h equals negative 2t squared plus 7t plus 4 models the toy's height h in feet from the ground at t seconds after he threw it. So there's a lot of information that's packed in there, and you might be intimidated by it. Okay, it says a lot. It tells you that his deck is 4 feet off the ground. It talks about something called initial velocity. That is the starting velocity. When he throws the toy up in the air, the toy leaves his hand as he throws it up, and how fast is it going when it leaves his hand. None of that though is like necessary for solving the problem. Now, if you look closely at the equation, you can see like the 4 feet, okay, is here. Here's the 7 feet per second. Now, this number, the physics me is kind of bothered by that, because that -2 is not any like gravity number that I am aware of. So there's like the standard and metric numbers that can come into play there. With gravity, I'm thinking that is the writers of the problem needed some numbers that were going to come out nicer for you, the doer of it, and so they kind of gave you a -2 there. So what we're going to do is approach this. Oh, well, here are the questions. How high is the toy after 1 second? So who is this? Your nephew. Okay. Throws it up in the air, and 1 second later, the toy is still in the air. The question is, how high is it? Second question is, what is the toy's maximum height? In other words, how high did the toy get? Notice that I'm paraphrasing each of these questions because they could be asked several different ways. And how long is the toy in the air? So let's hop on over to our graphing calculator, and that just changed my whole view of what I am seeing. Now, so suppose we just go and put that in as is. So you're cruising along, doing your classwork, everything is right in the world. And I am actually surprised. I did not think that was going to happen. So score 1 for learning something when you're recording a video. I really truly thought that Desmos was going to squawk at me for using H's and T's, because Desmos typically only recognizes X's and Y's. However, I'm thinking here that there's enough people using H's and T's for problems that maybe we're okay. So just to kind of look at what we got here, we're using H instead of Y. So this represents the height of the toy, and we're using T instead of X. So the X axis represents the time. Okay. We've got positive, and then we got negative. Okay. The toy is not going to go negative, increasing up to the vertex, and then it starts decreasing. So the first question that we're asked here is, how high is the toy after 1 second? So that we actually don't need the equation to do, or the graph to do. Now you could do it this way. So what I'm going to do is I'm going to click on the graph here and slide this up, and oh, no, maybe I'm not. There we go. And I'm looking for where the X coordinate is 1. So that now it's like half a second. So half a second, it is 7 feet up. Oh, sorry, it said 1.9. Just barely. Like I'm a little bit over it right now. 1 second, and it's like a little bit over 9 feet. There, oh, I was there. If you're watching closely, you should have seen it. Okay, there it is. So one way you could figure out how high is the toy after 1 second is to do what I'm doing. You just kind of want to hold the button down on your mouse, and you could just trace the parabola till you find the point you're looking for. Now, the disadvantage to that is that there's no guarantee that like it's going to be a nice number like 9. So the way you would do that algebraically is we would come over here and we would just plug in 1 for the t. Okay, so we would plug in 1, and lo and behold, when I plug in the 1 for the t, it is telling me 9. So you can do that either way, and I like that you have options for the way to do it, because everybody's different. So some of you are really going to want to do that by plugging the number in. Some of you might want to trace it on the graph there. Okay, so after 1 second, the toy is 9 feet in the air, and I need to be super careful about how I do this. Got my pen back. So 9 feet. Now the next question is, what is the toy's maximum height? The moment you see the word maximum, you should know that you are thinking vertex. Now, right now, if you look at the graph, you'll notice that the little dots are gone. If I want the dots back, I'm just going to click in this top window there. And this is what I meant in class when I said Desmos tries to read your mind. Okay, so it knows the key points on a quadratic that you are probably interested in. Okay, so it gives you the y-intercept, it gives you the vertex, and it gives you the x-intercepts. For the maximum height, we are looking for the vertex. So I'm going to go up there. Now, there are two numbers there, 1.75 and 10.125. One of those numbers is the maximum height. The other number is how many seconds it takes to get to the maximum height. And the question we are asked is, what is the height? So for us, that's going to be the y coordinate. So the x coordinate says 1.75. After 1.75 seconds, the toy is 10.125 feet in the air. So, but the answer for our question, and we always want to be paying attention to our question, is the 10.125 feet. And then the last question is, how long is the toy in the air? So let's come back over here and look at that. Okay, so at time 0, your nephew throws the toy in the air. It is in the air. If you watch where I'm pointing, in the air, hit maximum height. There it is. Still in the air, 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 still in, hits the ground. How do I know it hit the ground? Because the height is 0. If the height is 0, it's on the ground. Okay, so the height is 0, so we are interested in this point right here. I'm going to come over here and let Desmos highlight that for me. And what this means is after 4 seconds, the height is 0. If the height is 0, the toy is no longer in the air because it has hit the ground. So our answer for this would be 4 seconds. And before we leave this slide, okay, I want to explain some things kind of about how all this works. So the math is not restricted by real life. Okay, so for some people, like, they love that about math. Like, math, you can do the impossible. Okay, and so the equation that I have here, the function that we've graphed, does not know about this context. And so it is giving us the entire parabola. All right, so it's going into the ground because it doesn't know, the math doesn't know that we're like, it's a toy, like a stuffed animal hitting the ground. Okay, and so this would represent like the toy going below the ground. If we come over here and we look at this piece, this is negative time. Okay, because time was on that x-axis. This piece of the parabola would represent like going backwards in time. This does not have any meaning in this problem. Now, there are some problems where you might have a negative x coordinate that does make sense, but not in this problem. And so you, the doer of the problem, the person who is applying this to context, needs to understand that Desmos is going to graph more of this parabola. You need to know which pieces of it mean something for your problem. All right. Next one, we've got task 2. So this is the flying squirrel problem. So a flying squirrel jumped from a tree 11 feet in the air at an initial velocity of 9 feet per second. The equation h equals negative 2t squared plus 9t plus 11 models his jump where h is the height in feet and t is the time in seconds. So the whole premise of the problem is the same as the one we just looked at, except instead of your nephew throwing a toy, now it's a squirrel flying from a tree, okay? And that's just emphasizing the importance of getting practice, because there's only so many variations on this problem that people can give you, okay? They can change up the numbers, they can make it, I think later we're gonna look at like fireworks, you can look at somebody parachuting or like free falling. There's just only so many things that we can do. So once you've done a collection of these, you'll build some confidence that we're not going to throw too many curveballs at you. And then when you do see different kinds of problems, you'll have a nice foundation in some applications that hopefully can extend to others. So in this problem, we are asked, what was the squirrel's maximum height? So as soon as you see maximum height, you know you're thinking vertex. Question B, how many seconds after he jumped was the squirrel at his highest point? So just to make sure we are all good with that, maximum height means vertex, highest point also means vertex. So the problems are not always phrased exactly the same way. Maximum height, highest point. Those are both ways of saying vertex. And then question C, when did the squirrel reach the ground? Which is almost the same question that we had last time. One thing I do like about these particular problems is they change them up, they change the questions up, but not too much, just like a little bit. All right, so let's get that function in there. H equals negative 2t squared plus 9t plus 11. Now that has gone off the screen a little bit, so I'm going to click zoom out, see if I can get it back. There we go. All right, so my first question, what was the squirrel's maximum height? And then my second question, how many seconds after he jumped was the squirrel at his maximum height? Both of those are vertex questions. So I'm going to go over there and click on the vertex. So there's the answers to those two questions. You just have to make sure that you put the right answer in the right place. What was the squirrel's maximum height? That's your y coordinate. The y coordinate's always going to tell you what the maximum or the minimum is. So when we did our vertex form and we practiced finding maximum or minimum, we were looking at the y coordinate. So for this problem, the maximum height is 21.125. What are we talking about here? Feet. Okay. And how many seconds after he jumped was the squirrel at its maximum height? That was the 2.25. So the 2.25 is when did he get there? And the 21.125 is how high was he? Okay. Second question there is, when did the squirrel reach the ground? And I'm sorry, I lost my... Okay, hang on. I had to do that to find my cursor. So when did he reach the ground? So here's the squirrel. Squirrel started at the 11 feet, so that 11 feet in the air. So that's where he's starting at time 0. In the air, 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 reach the ground. There is where he reached the ground. And so the height is 0 because he's on the ground, and it took 5.5 seconds. Be mindful of your units when you do that, okay? So know what's in feet, or it might be inches or meters or miles, who knows, okay? And whether your other unit is in seconds, hours, days, it's possible, and I think we're gonna look at one in a few minutes, where the X would also be in feet. So don't go into autopilot with that, just pay attention to what is being described in the problem. All right, so enough of me. You try one. So if you are sitting at home, this is what we're going to do in class is I'm going to put brakes on me time in class, and you're going to talk about the frog sitting on a stump. So a frog sitting on a stump, 4 feet high, hops off and lands on the ground. During her leap, the frog's height h in feet is given by the equation h equals negative 0.5 d squared plus d plus 4, where d is the horizontal distance in feet from the base of the stump. So now our h is in feet because it's height, and our d value is also in feet because it's a horizontal distance. You are looking for what was this frog's maximum height? How far from the stump did the frog land? And what was the frog's horizontal distance from the log at her maximum height? So pause the video, hop onto Desmos, and get it done, and unpause it when you are ready to go over it and see how you did. Okay, hopefully you did that. Let's go take a look at this. So now I'm going to be surprised if it recognizes D, but maybe it will. No, it is going to recognize D. I am genuinely surprised. So you saw it here first. Okay, so there it is. Using what we know about definitions, when we see things like maximum height, and here's another maximum height down here, we know that that is asking us for something to do with the vertex. So coming over here, we'll like click on the vertex. So the vertex is 1, 4.5. Now we know from the previous problems, and because I said this, the y coordinate is always going to tell you the height. So for question A, if you were being asked what was the frog's maximum height, that is going to be 4.5 feet. Also, if it is a well-written problem, which not every problem is well-written, but if it is a well-written problem, the numbers should make sense. Okay, so if you are doing this and you get like a I don't know, like a frog is jumping and the height is like, 150 feet. Okay, stop. Now it's possible it's a poorly written problem, but double check that. Okay. Now you can probably use process of elimination here. If you know that question A and question C are both maximum height questions and you've used up the 4.5 on the maximum height, then C better be the number 1. So C was, what was the frog's horizontal distance from the log at her maximum height? So remember that in this problem, you've got D, which is the horizontal distance, and then H, which is the height. So we would be looking for 1, and it is also measured in feet. So don't go on autopilot, okay? You are being asked for a distance, and distance is not measured in seconds, okay? Which everybody knows that distance is not measured in seconds. Distance is measured in something like meters or feet or inches or centimeters or something like that. Now, the second question there is, how far from the stump did the frog land? So here we go, tracing our frog on her journey. She jumps off, maximum height, here it is, okay? So how far did she land? Landing is going to mean that it is your x-intercept. So let's go find that. Now, if it says how far from the stump did the frog land and you answer 0, this is what I need you to go back and say, does my answer make sense? We know that the frog is jumping off the stump and she's moving away from the stump. So if you give me the 0 for this, stop, think. Okay, think, does that make sense? Because that would mean she landed on the stump. So the answer has to be the 4. And remember that, I can't go back. Sorry. And I'm not going to, because you can just write the 4. Okay. 4. All I was going to do is put the pen on and write 4. That is just when I'm in record mode, I can't click back slides. In class, I would just go back a slide and write it, but it doesn't work when you're recording. So the middle one was 4. Now, the remaining classwork, you've got tasks 4, 5, 6, and 7. So there is a worksheet. If you hop onto Teams, you can see this. But what you might do if you're doing this from home, you can't print out the worksheet, just take a piece of paper, right? Put your name on it, please. Task 4, write down A, B, C, graph it, give me those answers. Task 5, and then take a picture of it, upload it to Focus, and you are good to go. Okay, or bring it back to class. But there we go. So that is the entire lesson on applications. And for the year that I am recording this video, which is 2023, 2024, we will have a test next class. So make sure that you check out the study guide. If you're watching this that particular year, make sure you go grab that study guide, which I will have posted online as well. I don't have it right yet because I don't have it written, but it will be there. And if it's a different year, just pay attention in class and see what's going on. All right, you guys know where to find me if you have any questions or you want to go over this, and I will be more than happy to help you out.